Now let's look at one quick example here of the cotangent function. My notes out. Here we go. So for the cotangent function, the basic process is the same. What's different about the cotangent is where we're going to get those asymptotes. So the period is the same as it was for tangent. We're going to use pi over b to calculate the period every time. And then to get the asymptotes, we're going to set bx minus c equal to 0 and pi. And the reason I'm using those is because if you go back to the original cotangent graph, the asymptotes in the original graph were at 0 and pi. So if there's any shifting, that's what we need to relate it to. So 0 and pi are going to be the equations we use for the asymptotes. And the intercepts, the halfway point between those is pi over 2. So we're going to set bx minus c equal to pi over 2 to get the intercepts. So let's try this example. It says graph this function. I'm going to ignore the interval for right now. I'm just going to let's do 3 cycles again. So start with the period. So the period is going to be pi over b, but there's nothing in front of the x. That's a 1, so pi over 1. So the period is just pi. To get the asymptotes, then we're going to set bx minus c, so in this case x minus pi over 2. We're going to set it equal to 0. And then we're going to set x minus pi over 2 equal to pi. Those are going to be our 2 equations. So solve each equation for x. We get asymptotes at pi over 2. And add pi over 2 on this side, we get 3 pi over 2. So let me go ahead and start my graph. I've got pi over 2 and 3 pi over 2 are going to give me my asymptotes. So let's go ahead and start those. The halfway point between them is where the intercept would be. So you can just figure out what's halfway between the two, but you can also use step 3, the equation here, to get the intercept. You're going to set x minus pi over 2 equal to pi over 2 again. Add pi over 2, you get x equals pi, which would be the halfway point, right? If you think about your unit circle, halfway between pi over 2 and 3 pi over 2 would be pi. So normally the cotangent graph, so pay attention to this part, the cotangent graph goes up on the left, down on the right. However, this one has something a little bit different. Notice that there's a negative in the front. So when there's a negative in the front, it reflects it over the x-axis. So whereas the normal cotangent graph would go up on the left, down on the right, this one's actually going to look more like the tangent. It's going to go up on the right, down on the left. And make a note that that's because of this negative sign in front of the a value. That's the reason that's there. So we're going to follow that pattern. Let's get the rest of them. So pi over 2, my next asymptote would be pi units later because that's the period. So negative pi over 2 would be the next asymptote. And then the halfway point would be, of course, at 0. So we're going to go up on the right, down on the left again. And then if we were to do one more cycle, negative 3 pi over 2, we'll do that one. And we could go in either direction. This is where I have space. So I'm going to do negative 3 pi over 2 over here. And then the halfway point between those would be negative pi. And so then we'll go up on the right, down on the left again because of that negative in front of the cotangent, in front of the a value.